Good morning, all of you. My name is Sai Kiran. I'm your chemistry lecturer. If you remember, in our last class, we discussed atomic spectra and detailed explanation of hydrogen spectrum. Today, we shall be discussing about detailed explanation of Bohr's atomic model. This is one of the important topic in our chapter, from which frequently questions are asked. Niels Bohr was the first scientist to explain quantitatively the general features of structure of hydrogen atom and its spectrum. This theory is only applicable for single electronic species. Single electronic species like it contains only one electron. For example, hydrogen. It contains only one electron. And helium plus one. Helium atom has two electrons. It lost one electron. It converts into helium plus ion. Now it has only one electron. Lithium plus 2. Lithium atom has 3 electrons. It lost 2 electrons. It converts into lithium plus 2 ion. Now it has only 1 electron. These are examples of single electron species. According to this theory, atom contains equal number of electrons and protons. So as a result, atom is electrically neutral. And next point is, electrons revolve around the nucleus in a fixed circular path called orbit or shell. Which means the radius of these orbits are fixed. It contains fixed radius. Each orbit has associated with different amount of energy, which means each orbit contains a fixed amount of energy. So these are also called as energy levels. And we know that the major drawback of Rutherford is, according to James Maxwell, when a charged particle undergoes acceleration, it continuously emits energy. Finally, it must fall into the nucleus, like this. But it doesn't happen. This drawback of Rutherford is overcome by Bohr with this statement. As long as electrons revolve in these orbits, they neither lose nor gain energy. So these are called stationary orbits. And electrons revolve in a circular path with associated some angular momentum. It is equals to the integral multiple of h by 2 pi. That is, mvr is equals to nh by 2 pi. Let's understand this. For example, when a particle with some mass moving with velocity v in a straight line, it associates some linear momentum. That linear momentum is equals to mass into velocity. Similarly, when a charged particle moves in a circular path, it has some mass and velocity v. In this, it associates some angular momentum. That equals to mass into velocity into, this is moves in a circular path. So radius also considered r. Now we want to know exactly how this mvr will came. Let's understand. Angular momentum is equals to I into omega. I is nothing but moment of inertia. That equals to m r square. And omega is angular velocity. That equals to v by r. This r, this square gets cancelled. Then we get m v r. Angular momentum is equals to mvr. mvr is integral multiple of h by 2 pi. Energy of electron can changes only when electron jumps from lower orbit to higher orbit. Means the orbit size is increases, energy also increases. This is the lower orbit, energy is E1. This is higher orbit, energy is E4. From electron jumps from E1 to E4, it absorbs energy. And electron jumps from E4 energy level to E1 energy level. It emits energy. The absorbed energy, emitted energy difference is equals to this energy graph. That is represented as delta E is equals to E4 minus E1, that equals to h nu. Here, delta E is the energy difference, E4 is the higher energy level, E1 is the lower energy level. Nu is the frequency of absorbed or emitted radiation. And we know that when a particle moves in a circular path, it experiences two forces. One is centripetal force towards nucleus side, and another one is centrifugal force towards outside. The centripetal force of an electron is balanced by centrifugal force. The centripetal force is produced by electrostatic attractions between nucleus and the electron. These are the important postulates of Bohr's model. Now come to the important formulas related to this model. First one is radius of nth Bohr's orbit. The centripetal force is equals to minus ZE square by R square. Let's understand. For example, this is an atom. Atomic number is Z. We know that number of protons is always equals to the atomic number. So here Z number of protons is there. Charge of proton is E. For one proton, charge is 1E. For two protons, charge is 2E. For Z protons, charge is ZE. That is ZE charge into electron charge is equals to minus E by R square. That equals to minus ZE by R square. This is the centripetal force of an electron. And centrifugal force of that equals to minus mv square by r. We know that centripetal force is equals to the centrifugal force. That is minus mv square by r is equals to minus ZE square by r square. Both sides negative gets cancelled and the square and this r gets cancelled. In this, we want to calculate the radius. M is the mass of electron we know, Z is atomic number and E is charge. In this, we want to know the V value. For that, we have a formula, that is MVR is equals to NH by 2 pi. From this, we can get the V value that equals to NH by 2 pi MR. Substitute this V value to in this formula, we get M into N square H square 4 pi square M square R square, that equals to ZE square by R. In this M, this square gets cancelled. This R, this square gets cancelled. From this, radius of nth Bohr orbit is equals to N square H square 4 pi square M ZE square. In this, except N and Z, remaining all are constant. By putting all these values and simplifying these, we get the value is equals to 0.529 into N square by Z angstroms. This is the radius of nth Bohr orbit. And the radius, when radius of two atoms compared, the ratio is R1 by R2 is equals to N1 square by N2 square into Z2 by Z1. We know that N represents the number of shell and Z represents the atomic number. Now come to the second one, energy of nth Bohr orbit. Total energy of electron is E equals to sum of potential energy plus kinetic energy. We know that kinetic energy is equals to half mv square. Till now we have three formulas. One is mvr is equals to nh by 2 pi, and another one is mv square is equals to ze square by r, and radius of nth Bohr orbit, that is equals to n square h square by 4 pi square m ze square. In this mv square is replaced with this value, that equals to 1 by 2 into ze square by r. This is the value of kinetic energy. And potential energy is equals to minus ze square by r. Now the total energy E is equals to sum of potential energy plus kinetic energy. ze square by 2r minus ze square by r, that is equals to minus ze square by 2r. The ratio of energy and potential energy and kinetic energy is equals to energy minus ze square by 2r. Potential energy is minus ze square by r. Kinetic energy is ze square by 2r. In the three terms, ze square by r is common, from which we get minus 1 by 2 is to minus 2 plus 1 by 2. Sorry, minus 1 plus 1 by 2. After simplifying this, we get minus 1, minus 2, 1. This is the ratio of energy, potential energy, kinetic energy. This is energy, potential energy, kinetic energy. And energy formula is equals to minus ze square by 2r. We know the r value, radius of nth Bohr orbit. Substitute this r value to in this formula. Then we get minus ze square by 2 into n square h square 4 pi square m ze square. These two times cancelled. Now energy is equals to minus z square e power 4 pi 2 pi square m divided by n square h square. In this, except z and n, remaining are constant. By putting these values and simplifying this, we get energy is equals to minus 13.6 z square by n square electron volt per atom. This is the total energy value. Now we want to calculate the potential energy. We know the ratio of energy, potential energy and kinetic energy. Potential energy is equals to 2 times of energy. So 2 times minus 13 2 is 26, 27.2 into z square by n square into electron volt per atom. And kinetic energy is equals to same energy and kinetic energy is same values, but sign is different. So plus 13.6 into Z square by n square electron volt per atom. When the energy of two atoms are compared, the ratio is E1 by E2 is equals to Z1 square by Z2 square into N2 square by N1 square. Now come to the third one, velocity of nth Bohr's orbit. For that we have a formula, that is mvr is equals to nh by 2 pi. From this, velocity v is equals to nh by 2 pi mr. We know the radius of nth Bohr's orbit is equals to n square h square by 4 pi square m ZE square. Substitute this R value to in this formula, we get V is equals to NH by 2 pi M into N square H square divided by 4 pi square M ZE square. In this M gets cancelled. This 2 pi square. And this N, this square, this H, this square. Velocity v is equals to ZE square by NH. NH 2 pi. Sorry. 2 pi. This is the velocity formula. In this all constant values, we can replace and simplify this. Velocity value comes out to be 2.188 into 10 to the power of 6 into Z by N meter per second. When velocity of two atoms compared, the ratio is V1 by V2 is equals to Z1 by Z2 into N2 by N1. Now come to the next one, time period. Time period is nothing but time taken to travel one revolution. That is, time period is equals to 1.5 into 10 to the power of minus 16 into n cube by z square. Seconds. When time period of two atoms compared, the ratio is T1 by T2 is equals to N1 cube by N2 cube into Z2 square by Z1 square. Now come to the frequency. Frequency of nth Bohr's orbit, that equals to, that is inversely proportional to the time period. So nu is equals to 6.66 into 10 to the power of 15 z square by n cube. Unit is second inverse. The frequency of two atoms compared, mu1 by mu2 is equals to z1 square by z2 square into n2 cube by n1 cube. Next one is ionization potential or ionization energy. The minimum energy is required to remove an electron from outermost shell. For example, this is nucleus, these are shells. This is outermost shell. The minimum amount is required to break this force of attraction and remove this electron. That much of energy is called ionization potential or ionization energy. For hydrogen, ionization potential is equals to energy of electron by N1 square. For hydrogen-like species, the ionization potential is equals to energy of hydrogen into Z square by N square. That is equals to 13.6 into Z square by N square. It's time to discuss drawbacks of Bohr's model. The first drawback is it was failed to explain the line spectrum of atoms or ions having more than one electron. And the second drawback is it was failed to account the fine spectrum details of hydrogen atom. Let's understand this. This is the spectral line. In zooming, it looks like this. This is called duplet because it looks two lines. How this happened? This was not explained by this theory. And the third drawback is it was failed to explain Zeeman effect and Stark effect. Now the question is, what is Zeeman effect and what is Stark effect? Let's see. Zeeman effect is nothing but the splitting of spectral lines of an atom into a group of lines in the presence of magnetic field is called Zeeman effect. And Stark effect is the splitting of spectral lines of an atom into a group of lines in the presence of electric field is called Stark effect. Let's understand. This is the spectral line. In the presence of electric field or magnetic field, it splits into group of lines. This is also not able to explain this theory. And good morning all of you. My name is Kiran. I am your chemistry lecturer. If you remember, in our last class we discussed particle nature of electromagnetic radiation. In that we covered black body radiation, Planck's quantum theory, photoelectric effect. Today we shall be discussing about second development towards Bohr's model, that is atomic spectra.